Ladies and gentlemen, welcome to RPI Data Science YouTube channel. So today I want to show you how to do pair plot in R and Python. If you remember, in my previous YouTube video, I was showing how to show correlation heat map in R versus in Python. So I was using cancer classification data. Then I was using R to do a heat map, a correlation heat map in both Python. And then in R, I mean in Python here, this nice correlation heat map, and also in R, this nice correlation heat map. So for this purpose, I was using cancer classification data, which comes from one of the machine learning courses that I was doing. So this cancer classification data, it has so many variables, numeric variables. So it's mean radius, mean texture, and so many other numeric variables. And at the end, our dependent variable is whether the cancer is, whether the tumor type is benign or malignant tumor. So it's one of I don't know, most commonly used dataset. You can also acquire this dataset in Kaggle, I think. But for this purpose, I will directly go to my plotting. So what I want to show is pair plot. Pair plot in Seaborn. It's really fascinated me. It really looks. I mean, I recently learned Python. I'm just learning Python. I cannot say I have advanced skill in it, but I'm going into the basic data science until machine learning. I have gone through it. It's really interesting, and I found this pair plot a very fascinating way of displaying or visualizing your data and how they are related to each other. You can choose a scatter plot, a scatter plot showing how one variable is related to each other. You can display that. At the same time, you can also choose the distribution, like in histogram or in kernel density estimation plots. So it's really short, but it looks very nice way of getting an insight from your data. But I was also interested in doing it in R and Python. So I'm using this SOS notebook. So you can see I'm changing my notebooks to R or Python depending on what I need. So for this purpose, I'm using SOS notebook. So I will directly go to my plotting. So I was checking whether there are actually packages where you can do any kind of pair plot in R. So I think there is one the base R function where you can simply use pairs and then simply pass your data frame and run it. You can have a very basic overview of your pair plot. So let's say for R data, my data in R is I called it like filtered R data because I was selecting only a handful of observations, handful of variables, only 6 observations. 5 of them are the independent variables, and the last one is a dependent variable. So I call this for R data, filter R data, and then I will pass this object with pairs argument. I mean, this basic base R function. So for pairs, I can have this kind of plot, but it doesn't really, I can get a rough idea of how the variables are related to each other and how it looks the distribution. How they are related in terms of scatter plot. So you can see some of, let's say in this case, there might be some kind of relationship. And then these ones, because I think one, because this variable is, these are, you can see, let's say this variable with it, they are like, let's say this is mean perimeter, and the next one is mean area. So mean area and mean perimeter, they are highly correlated. That's why you can have this kind of straight lines. because they are highly correlated. So this is one basic way of getting a pair plot in R. But you can also improve this by adding a few more arguments. Let's say I think there is a thing called BG group, the group variable. So you can add the color. Let's say in my case, what I have is this benign or malignant. So for that, I can use a color variable. So BGC, the way I do it is like you can pass, let's say the color. I can use one of them to be red and the other one to be green, let's say, or just turquoise. Maybe I like this color. And then you can add that variable. The variable that I want is as factor because I want to pass it as factor. So filter R data, and then this benign or malignant, here, and then I can simply run it. Probably I made a mistake in this color. Let's make it green instead. So I made spelling error. So I need this square bracket here. So now it should be possible to to run it. Maybe I need to close this bracket again, and now it should be able to work. Still, it didn't display the group. So I need to use BGC red, green, and then as factor. And maybe let me use this PCH equals, I don't know, 21, and then it should be, yeah, okay, now it's working. So it's yeah, I mean it's nice. You can kind of have a look, but it's not really as nice as the figures that I will show you in Python. So I think for pair plot, it seems Python is outsmarting R. So this Seaborn library, it's outsmarting it. We will see that. But we can also check if there are any other package that can achieve this pair plot to be nicer in R. So let's say I think the other package that I came across with is this package called ggali. So let me load this package first, and then the way you do ggpair, I mean in ggali, the way you do pair plot is like you use ggpairs, and then you can simply pass again my data, my data frame. So I can simply copy this and filter it here, and put it here, and then run it. Then I can simply have so it seems yeah, there are some ignorable errors. It's showing, yeah, and then it's showing me this. I mean, it's kind of better than this one. Yeah, but I think this one can be improved. So it shows the distribution, like a kernel density kind of plotting. It shows distribution, and then at the same time I can also see some histograms here and the relationship between each variable, and then there are correlations. So I think this one seems nice because it's also showing box plot for malignant, and non-malignant and benign and malignant. So it seems this one looks nice. If I have to work with R, I think I would prefer this, but this can be improved. Let's say by adding few other arguments, it can be improved. Maybe we can have the class. The last one, the last variable is my the sixth variable, which is a cancer, whether the cancer is benign or not. So we can have a coloring, so it may differentiate it by just coloring. So maybe we can pass this color instead by using color equals, and we can pass this one, the benign or malignant variable here, so we can put it here, and then let me check if it works. All right, okay, so it seems everything is in one color. It doesn't seem to show that by the variable color. Probably this variable is saved in, I don't know, in not as a factor. Maybe I should check is factor, and then let me check this. Otherwise, I would have to save it as a factor. Okay, but this is already a factor variable, but it's not really showing because I want it to be in two different colors. So probably there is additional things that we need to add, but I don't really know. I mean, I'm first time using this ggpairs package, but it seems it's interesting to have a detailed look. But with this color mapping, it seems it's not working to classify my data into benign and malignant, and showing the pair plots to be different. And then the next package that I came across was this package called WV plots, I think. So I can simply load it, WV plots. And then if I run it, so and then after that, what you can do is they have WV plots has pair plots, pair plot, and then you can simply pass your data again. They really have kind of similar functions. So it seems this one requires additional arguments. So the first one should be data frame, and then name variable list. So that means I need to give it the variable names. So that means I can use call names, and then filter R data, maybe like this. That's my data frame, because I want to give it call names, and then probably the last required variable should be title. So the title, I can use it simply pair plot. Pair plot is just a quick title, and then let me check if it works. It's taking a little bit. Oh yeah, okay. It's working, but it doesn't really look nice. I mean, this one is much better. Although I have difficulties getting it into different category of my observations, like benign and malignant. But this one is not really interesting. But maybe if we can improve it, maybe I think they have one additional argument. Maybe we can have a look. Maybe they have a group. This function may have a grouping variable. Yeah, okay, it has a group var. So that means you can pass a group variable and to differentiate the colors. So that means I can have two different colors. And let me see, two different colors in a sense for benign and malignant. Maybe the last one is let me give it group var. Maybe I can also give it this way. Group var equals this one, and not that one actually. The one I need is benign or malignant, and then can pass this. Let me put this instead, and I think what it requires is D data frame, and then let me scroll this up. Min vars title. Okay, D. So let me exclusively define the arguments. So min var, and then this one is D data frame, and then this one should be title. So then and the last one is group var. Now let me run it, and let me close this. Oh yeah, okay. It's not, I mean, it shows some kind of color distribution, that it's showing the difference between the benign and malignant, and it's showing some, but it's not really that I want. So this doesn't achieve my goal. I mean, this one seems better, but it didn't easily show the difference between the distribution of the data and the correlation for benign and malignant separately. So it's all plotting it all in one, but it seems this is something that I need to have a look in detail, because it seems that it's somehow achieving my goal, but it's not really. I mean, this one WV plot doesn't seem to be useful for my goal. I will check if there is any other package which does this, but at the moment the only ones I have is like to do pair plot in R, like these pairs from the base R, and then ggali, and that's based on the ggplot aesthetic ggplot function. So it's built from ggplot, I think. And then the last one that I have checked is this WV plots. I haven't seen, I don't know any other package which does achieve this kind of pair plotting in R, but if there is anyone, please let me know in the comment section. Now let me change my kernel to Python, and then see if I can easily achieve this pair plot in Python. So in Python, this seems to be quite easy. It's in one line of code you can have really a beautiful kind of pair plot. So you can use SNS pair plot, and then you can simply pass your data. So my data was saved as PyData. So this was filtered PyData. This was my data frame. I was selecting only 6 columns. The last one is a benign, exactly similar to the one I used in R. So I can simply pass this data to my to this SNS pair plot. So this is from Seaborn. So for those of you who are new to Python, I think it's nice to check Seaborn. It's really nice Python visualization library. So it has so many great plotting functions, and I found it's not really actually difficult to learn. So it's if you have a look at the gallery, they have all most of the pipelines that you need. So it seems I mean it's kind of easy to learn. So, and then I can simply so SNS pair plot filter per data. Then I can see what kind of plotting Python will do for this data. So remember, we have seen in R, these are the kind of pair plots that we have shown, and have a look at the number of lines of the code that we have to write in R. So using the base R function, and then using the ggali, and now again using WV plots, which doesn't seem to achieve what we need. And the last one is now I'm using the Python SNS, the Seaborn library, and you see how nice it looks like. It looks really beautiful. I really love this library. So you can also, I mean, this is just passing the whole data set SNS pair plot, and it's just one very small line of code. But I can also do the same what I did to differentiate this distribution for Python, I mean for benign and malignant. So for that, I can simply add one argument, and that's hue. So for hue, it's like in R, in ggplot2, you said fill or color or something, I think, and then I can simply pass that variable here, benign or malignant. Now I can run this, and then I can have this beautiful pair plot, which helps me to visualize my whole data set in two different categories. So you see, yeah, so it's very beautiful. It looks really nice. So I love this library really. So it seems for some packages, I mean for some visualizations, so it seems Python is outsmarting R. I think in I don't know. I personally like ggplot2, but it seems Seaborn is also worth looking at. So you can also add, let's say in this case, I have, so it's I can also add another argument. I think that's kind equals hist. Should be histogram, but let me check if it works. So the middle one will be histogram instead of the KDE. Yeah, so it's showing me a nice histogram here. Awesome. And let me check this if this is KDE. If I do kernel density estimation, it's taking a little bit of time. Okay, now it's coming. Wow. How cool is that? Yeah, okay. So that seems very nice. So I would go if you want to have a nice pair plot, to have an insight from your data, then I think Seaborn library is it seems to be much nicer. Maybe we can have a look how SNS Seaborn pair plot documentation looks like. So we have hue, we already did it. Hue order, we can also list them in the order that we like. I think we can also add additional arguments. Kind. I think there is one function, this diag. Okay, so let me choose diag. The diag we already hist, we have already chosen, and KDE we have already tried. Auto is the one with this. I think the default. Yeah, so it seems this library is really nice. So I recommend looking at it. I hope you find this helpful. It's a midnight data science class, so maybe my voice is a bit. Yep. Thanks.